Good day to you. This is teacher Leland, Alejandro. We're going to do solutions of exponential equations. We shall start with the examples on the other screen. So let's look at the problem set. Okay, let's have the problem set over here. Okay, this is the first number. What is the value of x in the equation? 3 raised to 2x plus 1 equals 3 raised to x plus 5. Now we're going to have the solution over in our first screen. All right. You will have to see that there's a 3 raised to 2x plus 1 and equal to 3 raised to x plus 5, and the bases are equal. So you can immediately conclude that when the bases are equal, the exponents are also equal. And so we can start with equating the exponents. You're going to have 2x plus 1 must be equal to x plus 5 there, because both bases are 3 on both sides, and therefore 2x plus 1 must be equal to x plus 5, the exponents. Okay, that's the rule in solving exponential equations. And then you can ordinarily solve the linear equation or quadratic equation, whichever is the case. All right, so you have 2x plus 1 equals x plus 5, so we will just solve this linear equation, and we will start by subtracting the smaller x. Okay, that's 1x, the other one is 2x. So we will just have minus 1x there. And so we're going to have 2x minus x is just x. You still have the 1. And this is now x minus x is 0. You only have now the 5 there. Now we're going to subtract the 1 so that we will get the answer. So this will just be minus 1 and minus 1. And so x is equal to 4. So that gives us the answer for the first number. Okay, let's have the second number. All right, the second number is over here. So we shall move downwards. Okay, here's the second question. Okay, for what value of x does the base is 1 over 9 raised to x plus 1 equals, here's the first part of the right side, 81 raised to x plus 1 multiplied by 27 raised to the exponent 2 minus x. And so if you're going to analyze this given, we have different bases in different forms. So the first one is 1 over 9 there. And then this is raised to the power x plus 1 there. That's for the left side. The right side is another base 81. And then 81 is raised to the exponent x plus 1 there. And then this is multiplied. It's a dot, so it's multiplication. And you have another base 27 raised to the exponent 2 minus x there. All right, so we have here 1 over 9 base, and then 81 base, and 27 base. Now, you should be able to figure out that these numbers can be expressed in powers of 3. Okay, so if you still remember, you have 3 to the 0, that is 1. 3 to the 1, that is 3. Powers of 3 now. And then 3 squared is 9. 3 to the 3 is 3 times 3 times 3, that's 27. Okay, and 3 to the 4, that is 3 times 3 times 3 times 3, that's 81. And so we can replace these numbers 9, 81, and 27 using powers of 3. We can express 9 like 3 squared. So you can write this 1 over 3 squared there. and then this is raised to the power x plus 1. And then 81 can be written 3 to the 4th. 3 raised to the power 4. That's your 81. And then this is still raised to x plus 1. There. And then this is multiplied. 27 can be expressed 3 to the 3. And this is raised to the power 2 minus x. There. Now, the expression at the left side, you can bring the 3 squared at the numerator, only you need to change the squared to a negative squared or negative 2. So you can put this on top. This is 3 to the negative 2. There. And raised to the x plus 1. Like that. Okay. Now, the right side remains the same. So this is 3 raised to the, you can multiply now the 4 and the x plus 1. So you have here 3. And then the 4 times x is 4x. And 4 times the 1. So you have there plus 4. There. Now the next term is times. You have there 3. 3 to the, you can now multiply the 3 and the 2. You have 6. The 3 and the negative 1x is negative 3x. There. And now you can now have all of them in base 3, okay? Base 3. So you can now simplify this by the law of exponents. You can have this 3 raised to negative 2x, and negative 2 and 1 is negative 2. There. And so we can now equate this to 3 to the 4x plus 4 times 3 to the 6 minus 3x. Now we can make the right side just 1 base 3. And we're going to add the exponents. 4x plus 4, you will add this to 6 minus 3x. So you're going to have here just 1 base 3 and raised to the 4x plus 4 plus 6 and minus 3x there. Now we have the left side and the right side with just a common base, okay? We now have a common base 3. We now have our working equation. Okay, our working equation is now negative 2x. We can now drop the bases 3, negative 2x minus 2. And this is equal, you can now equate the exponents. So negative 2x minus 2, remember we're now removing the base 3, okay, from both sides. We're now going to equate the exponents. So we have negative 2x minus 2 equal to, all right, let's simplify the exponent. This is 4x and minus 3x, so that will just be 1x or simply x. And then you have the 4 plus 6, okay, here, this will just be plus 10. There. Okay, so we can solve the equation, and you have here negative 2x. We can just continue over here in this tiny space here. We have there negative 2x minus 2. Let's just put it here. And then this is equal to x plus 10. All right, by way of subtraction, we have minus x minus x. We're going to have negative 3x. And we have the minus 2. The right side is x minus x. That makes 0. We only now have the 10. There. All right, we are now going to continue by way of addition of 2 to both sides to isolate the x term. So we add 2. and the right side is 12. And we have negative 3x, and we're going to divide this by negative 3, and we have the x already at this point. This is now negative 4. And we have the answer x is equal to negative 4. Okay, that answers our number 2. Let's continue with the third number. So if you don't have any questions, I will erase the screen. And we shall continue with the third. Okay, let's continue with the third. Here's number 3. Let's provide more space. Okay, which equation is equivalent to, the base here is 1 over 3 raised to x equal to 27 raised to x plus 2. Again, we encounter power of 3 here, power of 3. The 3 and the 27. So going back to our table, let's put a table here. 3 to the 0 is 1. 3 to the 1 is 3. Okay. 3 squared is 9. And then we have 3 to the 3. That's 3 times 3 times 3. That's 27. And of course, 3 to the 4th is 81. We don't need 3 to the 4th at this time. All right. Now, how about 3 to the 0? How come that is 1? How did you get 1 there? All right. I'll show you. Okay. By the law of exponents, let's go back to the law of exponents. You have here a to the m divided by a to the n, okay, must be equal to a in division like this, okay, of powers of a this time. You will have there m minus n. The exponent of the power at the numerator must be the minuend. And then the exponent at the denominator, which is the n, is the subtrahend. So this is m minus n. There. All right. How did you get 3 to the 0 equal to 1? Well, you can say 3 raised to 1 is 3. And then divided by 3 raised to 1 is also 3. So this is equal to 3, 1 minus 1. And this is equal to 3 to the 0. 1 minus 1 is 0. Okay. Now, any number divided by itself is 1. There. Okay. So 3 divided by 3, that's 1. That's why we have 3 to the 0 equal to 1. Right? So that explains why we have 3 to the 0 is equal to 1. This is also true with different number. So that we have 7 raised to 0, that is also 1. By the same explanation here. Okay? By the same explanation here. 7 raised to 0 is 1. 5 raised to 0 is also 1. 100 raised to 0 is also 1. Because that will eventually become a number divided by a number. Okay? And that is always 1. This is only true if the number is not 0. Okay? So 0 divided by 0, that is not defined in mathematics. All right, let's continue with our number 3 here. Now, let me just erase. Okay, let me just erase. All right, let's remove that part. Okay, let's leave the table right there for our reference. Okay, 1 over 3 raised to x. You can actually move that 3 on top because this is actually 1 1 over 3 raised to 1. There, like that. Okay? And this is raised to x. And this is equal to 27 now can be changed to 3 to the 3. 3 to the 3, that is 27, and you have raised to the power x plus 2. There. How come if you bring 3 at the numerator, it becomes negative 1? Well, remember, okay, let me just explain this part. Okay, 1 over 3 to the 1. Remember, your 1 is expressible to 3 to the 0. So this 1 here can be changed to 3 to the 0. Okay, and the number at the bottom is like that. Okay, following the one we have before, a to m over a to n is a to the m minus n. Following this law here, okay, that means 3 to the 0, okay, minus 1. So you have 3 to the 0 minus 1. And so this is 3 to the negative 1, like that. Okay, so our next line for the left side, we will have to use this, 3 to the negative 1, okay, bringing the 3 at the numerator. Okay, all right, so let me just remove that part. Okay, so this can now be changed to 3 to the negative 1 raised to x there. Okay, and this is now 3. You can now multiply the 3 and the x plus 2, giving you 3x plus 6 there. And the left side is 3. Negative 1 times the x is negative x there. And the right side will still be 3 raised to the exponent 3x plus 6 there. And this means like this. So we now have both left and right side of the equation with the same base 3. Okay, they are now the same. Okay, it's no longer 1/3 and 27. All right, we can now drop the bases 3 and we can just equate the exponents. So negative x now is equal to 3x plus 6. And this is now simple. We will just solve the equation, linear equation, and we will have the value of x. Okay, so we shall isolate the x now. We will subtract the 3x from both sides, like this. And we shall get here 0. All right, and we have negative 1x, negative 3x. That will add up to negative 4x there. And the right side is just 6. Okay, next step is to divide by the number beside the variable x. So our divisor is the negative 4. So we shall divide by the negative 4 and dividing both sides like that. So the x value, this is equal to x equal to 6 over 4 is 3/2, lowest term. So this is negative 3/2. There, let me write it clearly. Negative 3 over 2. There, that's the answer. All right, that answers our number 3. Okay, this is the answer. It's a fraction, negative 3 over 2. Okay, so we shall continue with the fourth. Let me clear the screen. All right, let's continue with the fourth example. Okay, here is the fourth example. Okay, for what value of x does 9 equals 1 over 27 raised to the power x plus 3? Okay, this is supposed to be like this. 9 is equal to 1 over 27 raised to the power x plus 3. There. Okay. Now, we have 9 and 27. All right. Just imagine the table a while ago. 9 is 3 squared. So we can write 3 squared. That takes care of the 9. And then the right side, 1 over 27 can be written 1 over 3 to the power 3. Okay. That's 1 over 27. Okay. The same exponent for the right side, x plus 3. There. Okay, so we're almost done with the bases. Only we need to put up the 3 to the power 3, making it 3 to the negative 3. So this will continue, the right side will continue 3 to the negative 3. And this is raised to x plus 3. Left side is the same as 3 squared. Okay, next line, we will multiply the negative 3 and the x plus 3 for the right side exponent. This will be negative 3x. The negative 3 multiplied by the 3, that's a negative 9. There. And the left side is the same. Okay, so continuing over here. All right, we can now drop the bases 3. We will just have the exponents equal. We will equate the exponents now. So we have 2. And this is equal to negative 3x minus 9. There. Okay, so we will isolate the x term now by removing the minus 9. Okay, we can remove that minus 9 by way of addition. So we add 9 here, and we add 9 here. All right, and you see this will zero out, and we will just have the right side negative 3x. And of course, the left side is 9 plus 2, which is 11. There. And so next step is divide. Okay, our divisor is always the number coefficient to the letter. So that is the negative 3. So we shall divide both sides by the negative 3 there. And so x, the right side, is just x because this cancels out. And the answer is 11 over 3. And it's a negative. Now, we don't write it this way. The x should be at the left side. So x is equal to negative 11 over 3. There. That's the answer. Negative 11 over 3. That should be for our number 4. Okay, so we shall continue with number 5. Let me just clear the board. All right. Okay, so this will now be number 5 next. Okay, we shall continue with the number 5 down here. We shall put this up and then hit the enter key so that the 6 will go downwards. All right. Here's number 5. Solve 12 raised to the power x squared plus 5x minus 4 equals 12 raised to the power 2x plus 6. So in number 5, we don't have adjustments to do. You can see the bases, they're the same 12. Okay. You can see from the given, it's a 12 and it's a 12. So we don't need to bother do any transformation to make them similar or the same. Okay, we can just simply proceed to equating the exponents. So we will continue with x squared plus 5x minus 4. That's the exponent of the left side expression. We can now equate this to the exponent of the right side, which is 2x plus 6. There. And so we will encounter here a quadratic equation, okay? A quadratic equation. All right, so we shall now put everything at the left side and make the right side 0. So we will subtract 2x. We will subtract 6. There. And if you do that at the right side, you also do that at the left side. So this is minus 2x minus 6. There. So the right side is immediately 0. All right. The left side is now a quadratic expression, x squared. And you have here a positive 5 and a negative 2. That results to a plus 3x. And you have here negative 4 and negative 6. That adds up to negative 10. There. Okay. You now have a quadratic equation which can simply be solved by factoring. Okay. The factoring. All right. So we can get the factors. This will have binomial factors. If you remember your factoring, okay, the factors of 10, 5 and 2. And 5 and 2 has the difference 3. So that fits exactly in the solution. So you put here 5 and 2. Okay, remember we have a negative 10. So the 5 and the 2 when multiplied must give negative 10. In order for us to do that, one should be negative and one should be positive. Now, our 3x is a positive, okay? So that means when you add the 5 and the 2, it should subtract. And so, to make it a positive 3, we will make the higher number 5 a positive, and the lower 2 is the negative. Okay, you can multiply this, and it should return to the expression here. X and x squared, you have negative 2 and 5, that's a negative 10. And then 5x and negative 2x is a plus 3x. Exactly what we're going to have equal to the left side. Okay, what do we mean by that? Just review your factoring. All right. Okay, just review your factoring. All right. Now this is now x minus 2 equals 0. We're now going to equate both factors to 0 there and come up with the answers. And we have here x equals 2 and x here equals negative 5. So here are the answers there. Okay, so this gives us the solution. Okay, this gives us the solution, and both roots are correct. So this is for number 5. Okay, all right, let's continue with number 6. Okay, number 6. All right, if you're done looking at the answers, let me clear the screen. Let's proceed to number 6. Okay, here is number 6. Okay, which equation is equivalent to 16 to the 2x equals 32 raised to the x plus 3. Okay, if you're asked to find the equivalent of this, then we shall find an expression similar to the above, okay, or similar to this given. All right, now this is 16 base and 32 base. This can be expressed using powers of 2. So if you will recall your powers of 2, we have here 2 to the 0, that's 1. 2 to the 1, that's 2. 2 to the 2 is 4. 2 to the 3 is 8. And 2 to the 4 is, how much is that? 16, yes. And then 2 to the 5 is 32. There. So the 16 and the 32 can be expressed as powers of 2. So we can write the 16, okay, this is 16 raised to 2x. This is equal to 32 raised to x plus 3, like that. Okay, replace now the 16 with 2 to the 4, okay, you can see it here, okay. You can see in this table here, the table that we have on the right side. So 16 can be expressed powers of 2, which is clearly 2 to the 4th. There. And then this is raised to 2x. and this is equal to 32 raised to x plus 3. 32 can be expressed 2 to the 5. There. And this is raised to the power x plus 3. Okay, you can now multiply the exponents. So the left side, you can have 4 times 2x, making it 8x. And of course, the right side is 2 raised to the exponent 5x plus 15. There. Okay, so the answer is this. This is the answer. Which equation is equivalent to this? Then this is the answer. Yeah. You're not asked to solve for x here. Probably you're asked to see a different form of the given. And this is close to it. All right. This must be the equation equivalent. There. Okay. So this answers our number 6, because the question here is which equation is equivalent to 16 to the 2x. So probably there's a selection or choices that you need to see and find this one. Okay, so that should be for number 6. All right, let's continue with number 7. Okay, number 7. Let's continue with number 7. Here is number 7. Let me put 7 up and move 8 downwards. There. All right. Here's the question for number 7. If 7 raised to 2x equals 7 raised to 3, what is the value of x? So far, this is the simplest because you don't have to transform anything with regards to the base. Okay, the same base for both left and right side. We have them base 7. So that means we can proceed immediately equating the exponents. So the way to solve this, you can start with the given. All right, you can write it first. And you can see base 7 and base 7, they're equal. When the bases are equal, the exponents are equal. So we can proceed removing the bases now. We will simply have 2x equals 3. And we have a simple linear equation here. Okay, next step is to divide by the number beside the letter. So our divisor is the 2. And x is 3 halves. There. That's it. We're done. Okay. All right. So what is the value of x? There's the answer. That's 3 over 2 positive. All right. We continue with number 8. Okay. Don't forget that. That's the answer. All right. Next, we have to see our next number. Okay. Let me just put 8 on top. There. And move number 9 downwards. Okay. Here's number 8. If 36 raised to 12 minus x is equal to 6 raised to 2x, what is the value of x? Okay, we're now presented with 36 and a 6. Okay, we can now relate the 6 and the 36. Using powers of 6 now, let's have the table first. I do it always this way. 6 to the 0, it's 1. 6 to the 1 is the number 6. 6 to the 2 is 6 squared. That's 36. 6 to the 2 means 6 times 6. All right, let's stop here. Okay, we don't need the higher values. We can now use the 36 and convert that to 6 squared. So the given is, this is the given. This is the equation. We're asked to get the x. All right, 36 can be replaced now with 6 squared. That's your 36, okay? And you still have this value raised to the power 12 minus x. And this is equal to 6 raised to the power 2x. There, you can write it that way. Okay, now you now have the base equal now. You only need to multiply this. There. Okay, so this is 6 raised to 24 minus 2x. Remember, you're going to distribute the 2. okay, you're going to distribute the 2 to the 12 and to the negative 1x. So the left side exponent will be 24 positive and negative 2x. And you have the right side 6 raised to 2x. Now we have the same base 6, okay? We can now drop the base 6 and equate the exponents. Equating the exponents, now we have 24 minus 2x is equal to 2x. There. Okay, so the way to solve this is, all right, make the one side on the x, and we can do that by way of addition. So you should know how to do your linear equations, okay, in order to solve problems like this. So you add 2x here, you add 2x here, and this zeroes out. And you now have 24 equals 4x. And we should continue over here. You now have, you can write it this way. 4x is equal to 24. Same thing, okay? All right. If A is equal to B, then B is equal to A, okay? Symmetric property of equality. So we can swap the positions of the left and the right side of the equations. And this will now be division by the coefficient of the letter. So our divisor is the 4. There. And 4 over 4 is 1. 1 times x is x. 24 over 4 is 6. Exactly 6. That's our answer. There. That goes to our number 8. Okay. Remember the steps here. You have to make the bases the same before you can equate the exponents. Okay. That's what we did in the first step over here. You have to transform the 36 and the 6 so that you will have to make them common base 6. So you have to know your numbers, okay? Powers of 2, powers of 3, powers of 4, powers of 5, okay? At least up to powers of 10, okay? Like that. All right, so that you can transform the bases into similar bases. This is actually the concept here. All right, so that gives us our number 8 solution. So continue with the number 9. Okay. All right. I think this is the last number. Okay. Here is number 9. Okay. Here is number 9. If let's put it up some more. Okay. If 8 raised to x is equal to 16 raised to x plus 2, what is the value of x? Okay, you can transform 8 powers of 2 and 16 powers of 2. Going back to our power of 2 table, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. Okay, we need 16, so 2 to the 4th is the 16. There. Okay, so we shall now replace the 8 and the 16 using powers of 2 equivalent. So 8 is 2 to the 3. Let's start from the given. 8 to the x is equal to 16 raised to x plus 2. Okay, 16 raised to, like that. That's supposed to be that way. Okay, there's supposed to be one piece. All right. So 8 can be replaced by 2 to the 3rd and raised to x. And here you can replace the 16 with 2 to the 4. And that's your 16 raised to the expression x plus 2. There. Now, under law of exponents, you can multiply the expressions, okay, at the exponent part. Okay, so the 3 and the x, that's 2 raised to 3x, like that. Okay, and in here you have 2. You have to multiply now the 4, distribute it to the terms at the binomial. So this is 4x plus 8. There. And you now have the left and the right side of the equation having the same base 2. You can now drop the bases and equate the exponents. Okay, so you now have 3x simply equal to 4x plus 8. There. And then you can now isolate the x now by way of subtraction. We subtract this 4x and 4x. Okay, this zeroes out. You have here a negative x. Okay, and this equates to 8. There, and we're not yet done. You have here a negative x equals 8. We're after x, not negative x. So that means, this means negative 1x. Okay, so we're going to divide this further by a negative 1 there. And so negative 1 divided by negative 1 is a positive 1. Positive 1 times x. So this is now x equal to a negative 8 there. That's the final answer. Okay, so that's it. All right, so that should be for our solution. Okay. All right. Okay, so I think this is the last number, and I hope you were able to learn from the discussions. Okay, so this will be it. See you later. Bye-bye.